Hey everybody, I'm Jesse Donkervliet. I'm a PhD student at Vrije Universiteit Amsterdam in the Massivizing Computer Systems group, and I'm here today to pitch our project on a serverless platform for the Metaverse. Now, the Metaverse is an emerging research topic, but perhaps I should say a re-emerging topic because the term was originally introduced in 1992 in a novel called Snow Crash by Neil Stephenson, whose name is now obstructed by my face, but which you can read if I lean to the side a little bit like this. So the Metaverse is attracting attention again due to recent technological developments and because companies such as Meta and Apple are pouring billions into its development. And you can see on this slide a couple of references to how the Metaverse is depicted in science fiction and the virtual reality devices that Apple and Meta are now developing in this direction. However, the closest thing to a metaverse that we have today are the highly popular gaming platforms such as Roblox, Minecraft, and Fortnite. And it's important to understand that these are not just games, but that they are really virtual spaces where people come together to socialize, party, conduct social activism, create, share, sell digital items, and so on. So really more of a miniature digital society than a game. And you can see a couple of examples of this on this slide as well. So virtual concerts, real-world brands launching products in virtual space, and so on. Unfortunately, although these platforms are attracting lots of people and users, our systems cannot currently support them. So our systems really fail in spectacular ways because we cannot build scalable worlds. And here again, you see a couple of examples. So a virtual music festival that has to be postponed because the servers crash, and large-scale online battles that result in the loss of millions of dollars of virtual assets. So these are assets bought by players for real money, which disappear because the system malfunctions. So we argue in this project that we can leverage serverless computing to improve the scalability of virtual worlds in general and facilitate a metaverse in particular. And we do so because serverless has a lot of beneficial properties for virtual worlds, specifically the simple scalability and elasticity properties, the fact that there is little to no operational effort because, again, this is moved from the system developer, now offloaded to the cloud operator, and the fact that you can have cost-efficient, fine-grained, utilization-based billing, which is very nice for highly dynamic workloads. And our previous work shows that even with the current serverless services available, we can already help increase virtual world scalability. So you see an example of that here. This is a simplified result from earlier work, where on the horizontal axis, you see maximum number of players supported. And on the vertical axis, you see different systems. And you see that our solution, Servo, the blue bar, which uses computational offloading using serverless functions, successfully increases the scalability over traditional approaches such as Minecraft, which you may know, and OpenCraft, an alternative in-house solution. However, there are still important challenges that need to be addressed to really provide good integration between gaming platforms and serverless services. Specifically, games are really real-time interactive systems with strict latency requirements. And strict in this context means something like sub 100 milliseconds. So this, of course, is difficult to guarantee with things like the well-known serverless cold start problem, but also just the performance variability that you get from serverless services. And another example would be that components in a virtual world, they really communicate a lot with each other and they can run for a long time, and their make span or runtime may not be known in advance. So also here, it's something that does not easily map to something like function as a service, for example, but maybe also too small for you to want to run in something like a container or a virtual machine. So in our vision, a metaverse would be deployed not as a monolithic large system, but really as a collection of small services that are dynamically scheduled based on things like current workload, available resources, and quality of service requirements. And this integration will require adapting both the design of the virtual world systems and the design of serverless platforms. And we are designing and building these virtual worlds and serverless platforms as part of this project. So the end result, the vision, that is depicted on this slide, where you don't need to read all the details, but the key takeaway is that there are lots of different small components that are scheduled dynamically based on current demand from users and supply in terms of resources, and that this all works fully serverlessly, so fully automated without user or developer effort. So if you're interested to see how this project develops, please talk to us, email us, and follow our work, and we would be really happy to keep you posted. So hope to see you in the metaverse. See you later.